Do you know, I was going to go on about the economy, and then I thought, no,
Mm,
I was one about the NHS,
mm.
and then I thought, no, they can wait until Thursday.
Yeah.
Right? So I'm going to go out. I've got kept them for Thursday,
Mm,
but this is what we've got for today, and you'll realise why
mm,
when I get through it. So some things happen, and we just don't know why or how.
mm. Yeah.
Heads or tails.
Mm,
Why does a coin fall as it does?
yeah.
It needs
Probability.
to be a reason, and only finding out the reason can tell what will happen next.
Mm,
Heads or tails.
mm. Yeah.
Scientists are flabbergasted as to how the universe is expanding. Don't get me wrong, we all know it's expanding,
Mm,
but what has left the scientists scratching their heads is the velocity the universe is broadening its horizons.
mm.
It seems to be in expansion a lot faster than the stargazers first thought. It's left them with an uneasy feeling of not understanding anymore how the universe works. They discovered it is growing at about 73.5 kilometers per second per megaparsec. A megaparsec is a unit of distance of 3.26 million light years. Now, of course, that's when my eyes started to glaze over. Because,
Uh,
I just don't understand any of this. You know,
yeah.
I just, it went way above my pay grades.
You and Neil deGrasse Tyson as well. Well,
Right.
he understands it, but he doesn't like it. Yeah. Yeah.
So me, who obviously is not, I'm not a scientist. I lost track a little bit.
Mm,
But anyway, the scientists said that the universe is expanding a lot faster than current models predict.
mm,
It marks a significant shift in perspective, they said, in the scientific journal Astronomy and Astrophysics.
mm.
They said their findings strengthen the case for a new physics or a deeper look at the early universe. The way they calculate the expansion just doesn't add up anymore.
No, that's science for you.
The early predictions said that the universe would expand at a rate of 67 kilometers per second per
Mm,
megaparsec. When the latest calculation put it more as 73, this is a massive difference in astrophysics.
mm,
This disagreement is called the Hubble tension and has been seen in various works lately. It's
mm.
not just this one.
Yeah.
So if the tension is real, this could lead it may point to new physics beyond the normal uh, cosmological model.
Okay.
So it's another kind of physics.
Yeah.
The team of scientists is composed of 40 researchers, some of from the Space Telescope Science Institute. So it's a lot of
Yeah.
serious bobbins
Yeah. Yeah.
on the sky. And they asked, will dark energy be overpowered by gravity and make the universe do a 180 on its expansion?
Yes. Yeah.
Will we go all out in a ball of flames as the stars and planets start to collide because there's less space in the universe for them to move around?
It kind of happens already. Yeah.
Well, I don't think it's in my lifetime they won't anyway. Well, I don't think so. But
Right.
why did I want to put this today? Is because on the back of what we discussed when we were on about the Artemis 2
Mm.
uh, podcast, and you said that physics is the same no matter where you go. It's always the same in the universe.
Well, it is. Yeah.
And I said, well, no, it isn't.
Well, this doesn't
It just
yeah. Yeah.
well, stop. Let me just
Yeah.
turn
Yeah.
out my
Okay. Yeah. Sorry.
turn
Yeah.
out my,
Yeah.
and then you
Yeah.
can. My point is that physics could be different somewhere else. We just don't know. And we can't base everything in the universe as to what we do know because it could very well be different.
Yeah.
And this is a typical example of exactly that. That they think they have to re-look at physics in general. So the physics that they use for the calculations for the universe are different than the physics here on Earth.
No, no,
Yes.
no, no, it isn't. It's um
So we will no longer be going 60 kilometers an hour in the car.
yeah, well, no, it doesn't change anything. What it is, it's a universal model of everything. They've not got the thinking right. This is what science is all the time. So when people say we're going with the science, what science are you going with? Yeah, science changes all the time. The way of thinking. It's a
Yes.
mathematical, in effect, it's a mathematical model that's got to be tinkered with, not tinkered with or rethought. Yeah, what 13.5 billion years ago, something happened that there was a great deal of something, a lot of much. No, there was a something, but of high mass and low. Yeah, it's very small, and it just erupted. Okay, what caused that? And yes, it's expanding. Now, it's only a. It doesn't mean that the laws of. It doesn't mean that things are different elsewhere. It means the universal law of physics, or the mathematical model, sorry, has got to be rethought out. Why is this doing? You can't suddenly decide that this is happening in this part of the universe, this is happening here, because that won't work, because that's colliding.
Well, this is what I'm saying,
And
Mark.
and and this is not what's happening. The physics on Earth is still going to be the physics on another planet. Doesn't matter where it is in the universe. Okay, you've got other things, anomalies that are always happening. Yeah, how dark energy works, they don't understand dark energy. Yeah, dark matter, dark energy. Um, so you have to get into it. It doesn't mean that the physics is changing. It means the way that the physics is applied has to be rethought out, or the mathematics in effect. Um, so I don't to say I don't see it as revolutionary is true. I it's just now a question of how quickly it's expanding. Why is it? How is our modeling wrong? What other things have come to light or anything else? And this is what science should always be. And this is what astronomy has always been. We now understand that stars are different distances apart. We know that we're looking at some stars that no longer exist, even some planets. When you're saying things colliding, um, galaxies have always been colliding, and the
Yes.
mathematical model is quite spectacular. We are due to hit Andromeda one day. Well, I'll say that we probably won't be about because we've only got about 7.5 billion years before our sun disappears or goes into red dwarf mode. Um, so, um, but no, I mean, you can't. I've heard this theory before. I remember on BBC had a stargazing program, and that what you said was muted. Oh, is it possible that in different places the laws of physics could change? They said not really, because if you start doing that, and this is where people, yeah, if I drop something on Mars or on the moon, it behaves differently from it does on Earth, why it does on Earth, because of different factors, the mass of the Earth and the pull, the gravity works, and everything else, and that's going to be universal across the whole of the universe. I can't see how that can't be. Yeah, and and it's going to have to be okay. We don't understand dark energy, but dark energy to work, we'll still have to have universal rules, laws. Um, you can't, you cannot change the laws of physics, Jim. But yeah, I honestly believe that you're going to have a universal model. There's going to be things and anomalies that will come into it. Why is this operating like this? There has to be a mathematical, logical reason why things happen. Okay, I mean, yeah, you haven't got some god somewhere just pushing things around with their finger. Yep, that's the only way it could change. And yeah, I'm very passionate. I mean, I'm not don't say that things, different ideas can't exist somewhere else, but I can't see it because if you start having different rules elsewhere, and when I'm not talking rules of speed to cars or anything else, that's a totally different man-made construct. This this is about attraction, repulsion. Why is everything still spreading out? Yeah, I've heard about this. Eventually, it will turn do 180, and then you have the big crunch. So you start with the Big Bang, and you go to the big crunch. and they've said it's probably there was a model that said it's happened many times before, which has been pretty much dispelled, actually, to be quite honest, as far as my understanding. So, I have a lot of problems if what you've just said, your statement is you could have a different rules elsewhere. I can't see how that would work if you've got one universe that's going round. God doesn't take chances. Yeah. Um, yeah. And
But it could
um,
be that it's all part of the get. It could be that it's all part of his plan, his major plan. That here it's going to be like this, there it's going to be like that, there
I
it's
mean, I
going to
mean,
be
I
like.
mean, okay, if we're talking about survival of the fittest or something like that, evolution, but I just can't see how. Okay, um, we have our solar system. Okay, the rules of our solar system are going to be pretty much the same. Yeah, and I'm sorry for any flat earthers out there. The Earth is round, and there's a reason it's round, and it's the way it interacts with everything else. Yeah. Um, I'm not sorry to any flat earthers, but you understand what I'm saying. Yeah, I'll sympathise with them. I'm not going to change them, but yeah. Um, Now, if we go if we leave the Milky Way galaxy, we go to Andromeda. We pretty much know Andromeda operates the same way we do. Yeah, we can see it. We can't see the Milky Way. Yeah, we can't. We don't even know how many arms the Milky Way has. Yeah, but we can see Andromeda. We can see other um galaxies. Sorry, yeah, galaxies. Yeah, and we know that there's different shapes. You've got um, the spiral galaxies, you've got the sphere ones, and etc. etc. And they all work in a slightly different way, but it's all uniform of how things interacted early on, that they're the way they are, and the tilt and everything else. I mean, we've even got different planets in our own solar system that spin in a different way to the Earth does. Yeah, our solar system. Yeah, but we understand it. It got hit and something knocked it to the side and things like that. Um, so it doesn't mean anything's different. And I don't believe mathematics changes. It's so illogical for me to even think that there's and I'm going down to this mathematical. I mean, everything comes down to mathematics. Yeah. Sorry about that, but yeah, we see. Even I have to refer back to something occasionally. Um, but I find it a very, very difficult concept to believe that things will operate up is down, down is up in other parts of the universe. I don't
Well,
just mean
me,
inverted planets or things like this. Yeah,
no, no.
I find it very difficult to think that something is so radically different. There could be a reason why things happen that we don't see. Like I say, we don't understand dark energy. Um, and we can't model it because we can't understand it. We can't model it. Um, and yeah, we've been trying to do research of it on into it, blasting things and everything else, and we're still nowhere nearer to getting it. When I say we, I mean it's a collective we.
Yeah.
Mine's far more superior to mine in the world of physics, and that's what people forget. Astronomy and physics is mathematical modeling. It's got nothing to do with, if you like, real world things. This works, yeah. Um, I mean, actually, I was watching a Funny enough, I just watched a quick video this morning by an author. He's actually a reasonably well-known author, and he does a series of short videos just about different themes and all that. He writes science fiction, he writes sort of fantasy books and things. And yeah, he was talking about this, is that when we do watch a science fiction film, Star Trek, for example, or anything, we'll never have warp drive because we can mathematically model how it would work and the folding of time and space, but we can't achieve it. Yeah. It's just a device for narrative talking. How do I get from here to here quickly? Yeah. I mean, we're still going to be months, if not years, away from getting man onto Mars with the traveling. Don't forget, yeah, and you've got to have something so reliable that it works. But again, how would we travel through things? We'd have to break the laws of physics in order to do that, really. Um,
Well, we'd have to what the laws of physics.
We'd have to break the laws of physics,
Yes,
and I'm
yes,
talking,
yes.
but
And I don't,
which means it's
I
not going to
don't
happen.
see. I don't.
You can't
Well,
break the laws of
Mark,
physics. You
What I
can't break the
see.
laws of, yeah.
Let's talk about what the Air Force, the U.S. Air Force pilots witnessed with the Tic Tacs,
Oh yeah, yeah.
and they said that they were doing right angle turns in the air.
Oh yeah, yeah. I know, yeah.
Right. So, is that down to physics that we know? Let's assume that there were tic tacs there,
Yeah,
and
I
they
mean,
were doing right angled
yeah.
turns in the air.
I mean, you could help. It's not so much you could stop an object like that and move it quickly, because if you put
Because
enough force to the other, if you put
birds,
enough force against it the other way, or put enough of a jet out like that, yes, it's possible. Yeah. It's whether if it had a pilot inside or not who could actually survive that kind of force. Um, how would you build a craft that would protect not necessarily human, anything else inside it? Yeah. I mean, I'm talking electronics or anything, because you do that could generate heat or anything else and melt stuff. Yeah. I mean, yeah, to actually do that, I would say is possible. It depends how rapidly. I mean, you couldn't just do that, but yeah, it would appear like that. You could actually do it if you had enough force either come from the craft to do it, or an external force to push it that way. Um, and how would you do that? But yeah, I mean, that's an argument. Yeah, it's possible. Something like that's possible. But
yeah, but
um,
your way of thinking is the traditional way of thinking in physics that you need to have a force greater than what is the velocity of the vehicle moving forward.
mm,
If there's a force greater that pushes it to one side,
equal
it
correct.
will
Yeah,
go. It will do a right angle turn.
yeah,
Yes, I understand that. Right. However, if there wasn't a force greater than
right.
the one at the velocity of because they were going quite fast apparently.
Yeah, yeah.
And
Okay.
once again, I'm assuming that these tic tacs were real, right?
Yeah,
That
that's the
the
other
what
thing.
they
Yeah,
saw, they actually saw. So so there was no evidence of any force greater than the velocity they were traveling
right.
to do a right
Yeah,
angle turn. So it could be that they know of some sort of physics where that could happen.
right. Okay. Okay. Let's just say it's extraterrestrial unknown physics. Okay. They would still have to adapt to apply it to the physics on Earth.
Not
Okay.
really.
So, well, you've just told me that the laws of physics would be different in different parts of the universe.
That's right.
Therefore, the laws of physics on Earth would be then, by what you've just told me, different from somewhere else, another galaxy somewhere, for
What I'm trying to
example.
get at, Mark, is that they could bring their contraptions
But
from
they would have, yeah, yeah, sorry, yeah,
from their place where they live,
yeah.
right? And then they can supersede what we because we're still using carbon vehicles to get to space,
Mhm. We probably will
right?
be for, yeah, the next 1,000 years
Quite
or
some
so.
time. So
Yeah,
you
yeah,
know that we are sort of light years behind, should we say?
yeah.
Right?
Okay,
We're
I'll
still
go
in
with
the
that.
dark age. We're
That.
still in the dark ages.
Yeah.
But if there was some way of doing this, where I mean, like I said in this little blurb here,
Mm.
right, that basically the scientists are stumped.
Well, yeah, but that's science for you.
Yeah,
Why is it?
and which is why I'm saying
Yeah.
is that you need to open your mind
Well, I've got an open
to
mind. I've said,
receive to and not declare it's just that there for the whole of the universe and God be damned.
well, I haven't
You
said that.
cannot, you cannot.
I have said I'll understand a mathematical model, and I'm not changing, but there would have to be a uniform. Okay, you're accusing me of this and that and the other, but a uniform mathematical model for the universe to operate here. I mean, we're only really aware of our own universe, really, and sorry, our own galaxy, and then what we can see, Andromeda and others there,
Yeah,
and
yeah,
in our own quadrant. Yeah,
yeah.
we know roughly where. I wouldn't say the edge of the universe is. We're still not certain about that, but yeah. And I I would still find being over, I mean, okay, I could go into the realms of fantasy and say yes, this could happen
Yes,
here.
you should. That's exactly it.
But that's a
Yes,
very
you should.
yeah. I will not do that unless somebody can say yes, that would work because I can't see how it would work, and it's going to be frustrating for you. Um, I mean, I like science fiction as much as anyone else. Yeah, I love. Yeah, and I accept that. Yeah, doing walk drives and everything else, which again would have to bend time and do other
Yeah,
things, and
right.
how would you protect the people inside? Because there's only a certain speed that us human beings, and then actually when you kick off a space shaft, you'd only need a quick burst of energy to make it go in one direction, and then you can shut off the engines. So that's
Right.
the other thing. But um, I'm if you said to most physicists or engineers that I've met in my life what you've just said, they would close. They would just close. They'd just walk away from you, quite honestly. Um, and yeah,
Well,
I
I
mean
mean, these guys, there's 40 of them. They
the
said they're
stuff.
going to have, they're stumped, and they have to. They said there has to be a new physics.
No, they said
That to me,
a revision
their
of the
words, not
physics.
mine.
No,
Their words,
a
not mine.
revision of the mathematical model. You can't have
No,
new physics.
that's
Phys-
not. Sorry, that's not what they said.
yeah,
They said they would have to revisit the birth of this
yeah.
universe,
That doesn't mean
right?
yeah.
Right, and they said that there may be a new physics, Their words, not mine.
You can't have new physics. You can have a new mo modeling, mathematical modeling.
And that's where we diverge.
You can't have a physicist who says there's going to be new physics. I mean, yes, you can have a new mathematical thing, rethink, and that's what science is. That doesn't mean that it's different in different places. It means we've got to have one universal model to cut again how it all began to understand more. But that's what they should be doing anyway. The Big Bang is still a theory. That's what it's called, the Big Bang theory. Yeah, where did it all come from? Um, it makes logical sense to our understanding now. Um, and it's always been accepted that really from since the 1930s. Yeah, but we are now trying to make sense of it. It's like I say, I mean, we got dark energy, dark matter. Dark matter holds everything together. Dark energies are things that are pushing things into different places. Um, okay, it's a little bit quicker than it is. It's speeding up. And what is the velocity? What is this dark matter? And that's where it is. When was that created? Um, to one was it 0.000 so many decimal points milliseconds after or after the Big Bang. Um, yes, it's mind blowing. Um, but you have to still have a start with a mathematical model to understand. And if you then start inventing things for over here, I mean, unless you've got proof that something's different from here to here, why is that? I mean, they know that there's certain I'm not going to say atoms are smaller than atoms, but uh, apparently disappear from this side of the universe and reappear over here. So travel. Why is that happening? Again, that's not logical. There could be a reason for it. Um, and or suddenly, yeah, disappear and appear here. Um, but again, that they've managed that in the lab. Yeah, apparently they've managed that in the transporter in Star Trek is theoretically possible. Theoretically possible. It's not. It's never going to happen. There's a lot of reasons, and yeah, um, basically it would take too long. And then there's the ethical thing. If I transported you from where you are to Alinda, would it be the same you that arrived in Alinda? Yeah. Um, yeah, so different things like this. But um, I, I, yeah, I can't see if you got a mass. Okay, I'm going to put the universe as one mass, one entity, and I would find it very difficult to accept. There'd be different rules elsewhere. I know what you're trying to say to me, to open your mind and think this, but as an engineer, I can't do that because if I did that, nothing would make any sense ever. Um, I know there's
Well,
a full.
it just shows the difference between somebody who's from an engineering background and somebody who's from an artistic background. Uh, the
Yeah,
the the different ways we think, and it's good. It's good. It's all good
I mean,
because
I
you know
haven't
what.
noticed. I haven't called you any names or anything. I put my case
I,
forward.
I hope
Uh,
not.
well, I wouldn't do, you know, but I don't like that on podcasts anyway. You know, calling each other names and things. I think it's, um, but yeah, I'm not. I find this is why I like science and it's astronomy because I've got books here from 30 years ago in front of me here, written by Patrick Moore. Um, I could go into there. The facts are there. Yeah, what they knew at the time. Yeah, and
That's what they knew at the time.
yeah,
What
and
they knew at
he
the time.
alludes to the fact that the exciting thing is that it's changing. We'll find out more.
Wow.
Our minds will be blown on occasions. Why is this happening? This shouldn't
Mm.
be like this. Why is this like this? But it doesn't mean that it's all going to be different. It just means we've got to go back. We've missed a decimal point somewhere or something like that. Yeah.
They said
Um,
that about they said that about this. They said that the difference
mm.
from 67 to 73 doesn't seem all that great. But when you're talking about astrophysics, it's immense, the
Oh yeah,
difference.
yeah, yeah. Oh
And
no, no.
it's more than just a displacement a fat finger
Yeah,
or
I know.
a point
I
up sort of
I
count.
know. I know.
It's huge.
Yeah, I'm making an interesting point here. Yeah, I mean, yeah, I mean, the
But
run that had.
if our calculations about physics is changing all the time, then I don't see why it can't be different in other places.
Well, there'll be other there'll be other factors why
Don't limit
things are
yourself.
different.
Yeah,
But yeah.
don't limit yourself to our universe.
Oh
There
God.
are others.
Oh dear. Here we go. Yeah. Again,
Yeah.
I, I, yes, I've seen all this. Do you mind? We're having enough trouble trying to understand our universe yet without, yeah. I mean, okay, I don't discredit anything, but I have a lot of problems accepting,
That things could be different somewhere else.
yes,